Alright, here we're going to take a quick look at the remainder theorem. Basically, the remainder theorem is this. If a polynomial f of x, so some polynomial, is divided by the quantity x minus k, so that's divided by this, then the remainder is f of k. So what this is saying is if I have some polynomial and I divide it by, say, x minus 4, then I can take the polynomial and evaluate it at 4 and I'll get the remainder. That's what it says. Alright, to prove that, let's look at this algorithm here. The division algorithm. Okay, the division algorithm says this. If you take a number and you divide it by another one, you'll get the divisor times the quotient plus the remainder equals the polynomial, right? And we can see that with an easy one. How about 5 divided by 3? Goes in there once. 5 minus 3 is 2. And this is how it works. The divisor, 3, times the quotient, 3 times 1, plus the remainder, 2, is equal to the 5. 3 times 1 plus 2 is 5. So that's the division algorithm written out for us. Now, the remainder theorem says, let me erase some things. The remainder theorem says that the remainder is f of k if you're dividing it by x minus k. So, let's take this and let x equal k. So let x equal k. I put x equal k, now x here is a k, and then the x here becomes a k. K minus k, that just comes out to be 0, right? And this is q of k, but I don't know what q of k is. It doesn't matter because 0 times q of k is 0. This all goes away. And then we have plus r. So the only thing left is r. When we take and evaluate this function at this value, which is the 0 to this, right? K is the 0 to that. I get the remainder r. So that's what they call the remainder theorem. Let's look at an example. If we take this polynomial here and divide it by this polynomial, we can work it all the way out and get the remainder. Or we could just have used the remainder theorem to find the remainder. So the function is, we'll set it up as minus 4x cubed minus 3x plus 1, right? And then divided by this x minus 3. Well, the k here is 3, right? Whatever makes this 0. So if I put f of 3, which would be negative 4 times 3 cubed minus 3 times 3 plus 1. Keep evaluating. F of 3 is equal to negative 4 times 27, right? Minus 9 plus 1. F of 3 equals minus 108 minus 9 plus 1. And f of 3 equals negative 8, so minus 116. So this would be the remainder if we were to do this division out. And now maybe I might do that with synthetic division quickly to see if I get remainder 116, negative 116. So we'll write negative 4, and there's no x squared, so 0 minus 3 plus 1. Those are the coefficients, and then my k is a 3. We drop down. 3 times negative 4 is negative 12. Add down negative 12. 3 times negative 12 is negative 36, right? Add down. 3 times negative 39 is minus 117. Add down, negative 116. There's my remainder. So the remainder theorem just gives you the remainder. Why would I want to use the remainder theorem? Well, all I'm interested in is this divisible by this? Can I factor this out? If I can divide it out evenly, meaning if the remainder is 0, then I would do it. Like x squared minus 25 divided by x minus 5, right? We looked at that. If we use the remainder theorem there, the 5, put a 5 in there, we get 25 minus 25, 0. The remainder is 0. I know that this is a factor of this guy. I know that this is not a factor of this guy. The remainder is negative 116, so we don't need to divide it out.